Alright, so we're working on number 2 of the circuit section, lesson 1.2, energy sources. Let's start a new slide for that. We have a circuit here that I'm going to redraw on here so I can see it better. We both are looking at the same thing. So we have a 9-volt battery connected to resistor 1, connected to resistor 2. I'm going to put it on the side. It really doesn't matter where it is as long as they're still in series. So R1, R2, R3. R1 is 470 ohms. R2 is 1.2 kilo ohms, but just for sanity's sake, I'm going to write 1200 ohms because I tend to forget to do that. And R3 is 270 ohms. Alright, now we need total resistance, total current, the voltage across R1, voltage across R2, and the voltage across R3. It's a lot to figure out. So, as we do this, throw this over to the other side, leave that up, do my voltages in blue, and then use Kirchhoff's laws to do that. Alright, so we're in a series circuit. So in series, all of these resistances are going to add up. The electrons going through have to go through each and every single one of those resistors. So it's the difficulty is going to add up. So total resistance is R1 plus R2 plus R3. All right, so R1 again is 470 ohms. R2 is 1200 ohms. R3 is 270 ohms. Grabbing a calculator, got 470 plus 1200 plus 270 equals 1940 ohms. That's my total resistance. That's what the resistance the battery experiences. Because again, the battery doesn't know what it's connected to. It's just experiencing that much total resistance. So that's part of what I wanted to find. If I want the that's my Ohm's law. That's relating my current, my voltage, my resistance, or I also tend to write it like this. I kind of like writing it like that because that reminds me that more voltage equals more current, and more resistance equals less current. So if that is true, and I want my total current going through all of that, I use my total voltage and my total resistance. So total voltage was, let's double check, 9 volts. And the resistance was 1940 ohms. And that's going to give me my total current of 9 divided by 1940. I get a very small number, 0.0046. 0.0046 amps, or 4.6 milliamps. Now when I solve for everything else, I may still keep it in amps as I use it for the different resistors, but sometimes it's easier to report the total current in milliamps. It's a small number. Alright, so I have total current, I have total resistance. Now this is a series circuit, and there's only one path, so the current that's going through here is the same current that's going through here, going through here, going through here. All of that current is the same. There's only one path, there's only one way for the electrons to go. What will be different is the voltages across each one of these. So the voltage across R1, or otherwise known as V1, the voltage across R2, V2, or the voltage across R3, which is V3. But voltage is current times resistance. And the voltage for the first one is the current through the first one times resistance for the first one. But the current is the same for all. So I have 0.0046 times 470 ohms. That's 0.0046 amps, I should say. Times 470 ohms. That gives me 470. I kept the answer in my calculator, so if you get a slightly different number because you rounded, it's not a big deal. 2.18 volts for V1. Alright, that's my V1. If I want V2, I guess I'll go over the right over here. V2 equals, again, the current, which is the same for all of them, R2. So 0.0046 times, let's get rid of that, 1200 ohms, this is in amps. Plug that into a calculator, times 1200 equals V2, 5.57 volts. That's my V2. Alright. Now I'm going to find V3 and double check against Kirchhoff's voltage law to make this work. Because all of the voltage, if I'm going to have 9 volts over here, right, that's how much energy per charge I have. I'm starting with 9 volts. I use some of them in R1, I use some of them more in R2, and I use whatever's left in R3. But I have to use all of it. All of it is going to get used. It's going to end up with 0 volts, 0 energy per charge before it enters the battery again, or the power source again, and gains more volts. So the total voltage should be V1 plus V2 plus V3. As long as I know 3 of these things, I can always find the 4th. Because the total voltage is 9 volts. V1 is, what did I get? 2.18 volts. V2 is, what did it say? 5.57 volts plus V3. Now I just have to solve for V3. So I have 9 minus 2.18 minus 5.57, and V3 would be 1.25 volts. Now that should work, and because I'm out of room, I'm not going to do it on here, but it should also work with the current times the resistance. 270 times 0.0046 should still be about 1.25. And if you get a hundredth off, it's not a big deal in this case. I'm not going to worry about that because that's just a rounding thing. But that's solving for a series circuit.